This is section 4.4, and this is part B in Hawks. So if we're talking about two lines that happen to be on the same graph, those two lines can either never touch each other, in which case we say they're parallel, or they touch each other. Those are your two choices, right? Either they don't touch or they touch. Now, if they do cross each other, if they do touch each other, there's two ways for that to happen. If they happen to cross each other and form a right angle, then we say the two lines are perpendicular. Otherwise, if they just cross each other wherever, then we say that it's neither parallel nor perpendicular. Okay? So, two lines either don't touch or they do touch. If they do touch each other, then they can either touch at a right angle or not. So we have parallel, perpendicular, and neither. And by neither, I mean neither parallel nor perpendicular. Now, parallel lines have the same slope. That makes sense because the slope is the steepness or the incline or the rate of change. So for these two to have the same exact incline would make sense. If they're inclining or if they're increasing at the same rate, then they're not going to touch each other. Perpendicular lines, on the other hand, have slopes that are opposite reciprocals. You may have also heard them say negative reciprocals. So just to kind of show you what I mean by opposite reciprocal, I mean the opposite sign and the reciprocal. So I just listed out a few slopes over here, and then what I mean by opposite reciprocal. So for instance, 3/4. The opposite of 3/4 is negative 3/4. So there's the opposite. The reciprocal flips the numerator and the denominator. Okay? So the opposite reciprocal would be negative 4/3. So if you have two lines, one has a slope of 3/4 and one has a slope of negative 4/3, those two lines will be perpendicular. The opposite reciprocal of negative 1/6, the opposite sign would be positive. The reciprocal would be 6/1, which we know just simplifies to just be 6. If you have a slope of 5, you can think of that as being 5/1. The opposite reciprocal would be the opposite sign, negative, and then the reciprocal of 5/1 is 1/5. The slope of negative 1 you can think of as negative 1/1. The opposite sign would be positive, the reciprocal 1/1, or just simply positive 1. Now here's the tricky one, 0. Now remember, all three of these were integers that did not have a denominator explicitly stated. So they all have 1 as their denominator. So 0 is no different. It's 0/1. Now, if I take that and I do the opposite sign, then I take the reciprocal, look, I get a 0 in the denominator. That means it's going to be undefined. That makes sense, right? Remember those special cases? Yeah, if the slope is 0, it's a horizontal line. What is perpendicular to a horizontal line? The undefined slope of a vertical line. So horizontal and vertical lines are perpendicular to each other. Okay, so let's start off with determining if two lines are parallel, perpendicular, or neither parallel nor perpendicular. So looking at these two lines, one of them is negative 2x plus 3, the other one is negative 2x minus 1. Pretty easy to see their slopes, right? Because it's in y equals mx plus b form. So you could easily see that the slopes are both negative 2. So these lines are parallel. It's a little harder if they're not already in y equals mx plus b form, like for this example, right? That one, you might want to just put it in y equals mx plus b form, especially if you're going to have to graph it anyway. So I did that for each equation. So for the top equation is all on this side of me solving it for y. The bottom equation is all of this of me solving it for y, and then identifying the slope as being that coefficient of x. So for this one, to get y by itself, I subtracted 2x from both sides and then divided by 3. Remember, if you divide by 3, I could have divided by 3 twice for each term, or I can divide it by 3 and just know that I do have to divide both the 5 and the negative 2x both by 3. So that gives me this equation. Over here, to get the y by itself, I have to subtract 3x and then divide by 2. Same thing, I do need to divide both of these terms by 2. And we get that these two, now be careful. Yes, those two are reciprocals, but they're not opposite reciprocals. They are neither parallel nor perpendicular. Now, here's the thing about this last example. There is a shortcut to find the slope of a line in standard form. If your line is given in this form, just to kind of show you the work of how I'm going to get here, you subtract that x term and then divide by the coefficient of y. So here's what we get. We get that this formula of negative a over b is a formula we can use to always find the slope of a line in standard form. Right? And that standard form being ax plus by equals c is that formula of negative a over b. That's pretty darn cool. So if we look back at the previous example and we go ahead and identify what is a, b, and c, then we can get to that slope a lot faster than if we were trying to solve it for y and get that y equals mx plus b form. So looking at this previous example, we have right here that a is 2, that's the coefficient of x. Then we have b equals 3, the coefficient of y. So negative a over b, there's my formula, negative a over b would be negative 2 over 3 is my slope. All right, here my a value is 3, it's the coefficient of x. My b value is 2, the coefficient of y, so negative a over b, the negative is just part of this formula, and that is my other slope. Now if we flip back really quick, we can see that that's exactly what we got for the two slopes with just a lot more work. So this method is super duper helpful. So you might want to make a note of this somewhere if you're keeping track with a formula sheet or something, right? Okay, so let's look at another one then. 3x minus 4y equals 16. 4x plus 3y equals 15. Again, we identify a and b, and we make use of this nifty Skippy formula because these are in standard form. So that formula for slope here, that negative a over b. So we get negative, a is 3, b is negative 4. Those negatives divide out to give you a positive 3/4. For the bottom equation, negative a over b gives me negative 4/3. Now look at these two. They are opposite reciprocals. That means these two lines are perpendicular. All right. Let's move on here. I know I go a little fast in these videos, and I do that because you guys have the ability to pause and rewind and things like that. So, all right, let's find the equation for the line that is perpendicular to x equals 5 and goes through the point negative 1, 2. Now, believe it or not, this one's going to be pretty easy because it's a special case. You know, whenever you see those vertical and those horizontal lines, those special cases, that if you recognize it, things can be quick and painless. All right, so x equals 5 is a vertical line, so it looks like this. So if something is perpendicular to it, then a line perpendicular to that must be horizontal. That's one of the special cases where y is a constant. Now, how do I know what number y is going to be? Well, I went ahead and just graphed it for you. This is what the graph of x equals 5 looks like. You know, it's find 5 on the x-axis, draw a line through it. All right? Now, the point, the specific point that was given here was the point, what, -1, comma 2. It's that point right there. So here's that line of x equals 5. Here's the point that it's going through. We know that it's a special case, so it's going to be horizontal here. So how did I pick 2? Why didn't I pick 5 or -1? Why did I pick 2? Well, because it went through this point. Remember, this point has the form of x comma y. So the y value of this point here is 2. So that's why I chose that. Okay. Let's find the equation of the line that is parallel to the y-axis and passes through this point. This is another special case kind of scenario. Parallel to the y-axis. Well, the y-axis, you know, runs up and down. So parallel to that would be up and down, would be a vertical line as well. We know vertical lines are x equals a constant. Here's our point. Remember, x comma y. So it looks like our answer is going to be x equals 2. So did you hear all that went through my head here? So parallel to the y-axis. Here's the y-axis. Parallel is vertical. A vertical line is a special case. So it's an x equals a constant. How did I know which constant to go with? Well, I went with the x value of the point that was given. If this had said perpendicular, then it would have been a y equals, I would have gone y equals -4. Okay. Example 5. Find the equation of the line parallel to the line 2x minus y equals 4 and passing through the origin. Now the origin is just the name that we give the point 0, 0. All right? Now, here's the thing. Our given line is given in standard form. We need its slope. We have a point for the line we're looking for, but we need the slope of that given line. All right? So, since it's in standard form, I'm going to use that shortcut, that -a over b. A is 2, b is -1. So I'm going to do that -a over b business, and I get a slope of 2. Because it's parallel, the line I'm looking for is parallel, so it has a slope of 2 also, same slope. And it goes through that point 0, 0. All right, now we're in business. Now we're in familiar territory, because we know what to do if you have a slope and a point, right? You have this y equals mx plus b. So you're going to plug in 0 for y, 0 for x, 2 for m. That's going to be 0, so you end up with b equals 0. So my equation is y equals 2x plus 0, or just y equals 2x. So that 2 comes from this slope. This 0 comes from that b value, and I simplified it because you don't actually have to write that 0 right there, okay? I'm sorry if you guys hear any squealing in the background. I have my windows open, and I kind of live near the train station, so at night we hear a lot of train stuff, so you might hear some squealing in the background. I'm sorry about that. Okay, example 6. Let's find the equation of the line that is perpendicular to this line and passes through this point. Same process as before. I'm going to find the slope of this line, and because this is perpendicular, I'm going to use the opposite reciprocal. Alright, so first things first, I need to find the slope. Because it is in standard form, a lot of these are given to you in standard form. That's why that little shortcut, that -a over b, is so glorious. because it is so much easier than trying to get the equation into y equals mx plus b form. So this little shortcut is nifty skippy. Oh, I got cut off. So that's -2. Man, that's a hot mess, isn't it? That is just a hot mess. Let's just scribble that out and try again. Okay, much better. All right, so the line we're looking for is perpendicular to this line, so its slope will be the opposite reciprocal. Remember, -2/1, the opposite is going to be a positive, the reciprocal is 1/2. All right, so the line I'm looking for has this slope of positive 1/2 and passes through that 6, -1. Now we're in familiar territory. The y equals mx plus b, where we just start plugging stuff in. All right, so I'm going to plug in the slope, the x and the y from the point. 1/2 of 6 is going to be 3, so I'm going to subtract 3 from both sides. I end up with b equals -4. Now that's not my final answer. I am just accenting that so that you can see over here how the b comes in to the final answer, as well as the m. Now, how did I know which m to use? How did I know to use the 1/2 and not the -2? Well, I only needed the -2 long enough to tell me what the slope is of the line I'm looking for. The line I'm looking for was perpendicular, so I needed that opposite reciprocal. That's the slope that I need for my final answer. So that's why, if you look at this and you're like, holy cow, she writes a lot. Yeah, I do. I do try to write a lot so that you can follow it better. It's not just a bunch of meaningless math and stuff. Okay. Let's find the equation of the line parallel to 4x minus 5y equals 8 and passing through the point 1, -2. At this point, I think it's a good idea, if you were to pause the video, try to work this one, because we just did 2 examples like this. So pause the video and see what you can do with this. All right, I trust that you paused it. All right, since it's in standard form, you know what we're going to do. We're going to use that shortcut. So identifying a and b, my shortcut is the formula -a/b. So plugging in a and b here, I end up with a slope of 4/5. Now, the line that I'm looking for is parallel to this, so it will have the same slope as this one. Okay, familiar territory. We've got a slope of the line we're looking for, and we have a point. So, substituting that into the y equals mx plus b, we get this. I'm going to subtract 4/5 from both sides. And again, you can use your calculator over here. I just kind of made a note of what I was doing on the calculator. It was -2 minus 4/5. So we'll kind of make that little fluffy little thought cloud so you can see what's going on. And I get this is my b value. Remember, this is not my final answer. I'm simply accenting this. I don't know if you can tell that it is in blue, but I'm accenting it in blue so you can see that it's in blue up there. So my slope here is in red, just to show you how my final answer comes together with all of these pieces of the puzzle coming together. Okay, last one, example 8. Find the equation of the line perpendicular to 2x minus y equals 7 that has the same y-intercept as this line. All right, this is just straight up mean, isn't it? I mean, there's so much stuff that's got to be found here that it's a mess. All right. Just like always, we're going to go ahead and start with this. We're going to find the slope of the line we're looking for. It is in standard form, so using my nifty skippy little -a/b formula, I get the slope is 2. That means that the slope of the line perpendicular to that is the opposite reciprocal. All right, so far, the line I'm looking for, I've got a slope. That's all I've got for now. I'll come back. Now, let's go to this other line. I need the y-intercept of this one. So for this one, I'm going to solve this for y and get it in y equals mx plus b form. So I divided both sides by -3. That means I did have to divide both this 6 and that -x. So I wrote it as, all divided by -3, but really it's the same thing as this. That simplifies to be this equation in slope-intercept form. Now here's the takeaway from this equation. This -2, that's my b value. That's my y-intercept. Okay. So here's what we get from that. We get that b is -2 from that second equation that was given. Okay. And we get that the slope is -1/2. We got that from the first equation that was given. So remember this first one up here? We found its slope to be 2, its opposite reciprocal. The perpendicular slope was -1/2. And then that next one, we had used it to find b. So we solved it for y, found that y-intercept. Now how did I know this is the y-intercept and not the 1/3? Because the 1/3 is the coefficient of x, so it's the slope. So this is my y-intercept. That's that -2 value. And we'll pull those two together for our final answer. Okay, that concludes section 4.4b.